MSC Software recently released Atoms version 2020. Enabling user productivity is the focus of this release. In this video, we'll discuss a couple of new features and functionality that will help you make your Atoms user experience more productive. Till now, the Atoms User-Defined Element, or UDE functionality, was exposed only via the Atoms View command language. Release 2020 provides a more graphical and interactive way to author UDEs. The demonstration model is a hexapod platform, and we will build the actuator struts only once, but then replicate it in different locations with different installation lengths. The UDE definitions can be stored in the model or the library. We will highlight both approaches. The user starts by selecting the topological objects to create the UDE definition. This UDE definition can now be replicated into multiple instances to connect the base plate to the platform. Design variables exposed as parameters in the UDE definition can be set independently for one instance compared to the others. For example, the lower strut radius for a strut can be larger than the other instances, since this was a parameter in the UDE definition. Design variables that are not exposed as parameters in the UDE definition, as an example the bushing stiffness, cannot be modified independently for each instance. However, we can update all instances of this design variable via the strut UDE definition. The UDE can also be created and stored in a library. A library is an Atoms View database object that can store other objects, such as UDE definitions. Libraries exist outside of models and enable users to share definitions with other users in the organization. To share a library resident UDE definition, users must export a partial binary, a version of the bin file. As shown, the UDE functionality provides a powerful means to create higher-order objects as repeatable submodels to make your Atoms usage more productive. The Atoms View temporary settings capability provides a convenient means to specify sets of model parameter data and/or solver settings that can be applied temporarily for a given simulation without altering the baseline model. The demonstration model is a robotic arm with a gripper at the end set up to pick a weighted payload. Let's create a set of temporary settings for the solver using the Temporary Settings button in the Design Exploration tab. We will set integration formulation and the integrator error to a value that is different from their default or baseline values. We can export out these settings in a separate file. We can now run the model with the temporary settings enabled and compare and contrast the results against the default settings. You can verify that the settings were applied only temporarily by looking at the Solver Settings tab. You will notice that the defaults of the formulation and error are still at their baseline values. If you want to use the temporary settings values instead of the baseline settings from now on, you can do that by using the Update Nominal Model button. The temporary settings files are not just limited to solver settings and can be used to modify design parameters as well. As an example, you can set temporary values for the coefficients of friction involved in the gripper claw to payload contact. To help users recall which temporary settings files were applied, an audit trail has been implemented in the analysis object, the ADM file, and the MSG files. Leverage these new features in Atoms 2020 for a more productive user experience.